In the second lesson, where we examine trig identities, we're going to honestly just practice these things. And this is a really tough concept, so it takes a lot of practice. As I said yesterday, there's no real follow to this procedure to get the right answer. You have to be able to think. But there are some general suggestions we can talk about for proving things. Okay, suggestion number one is try and use sign and cos whenever possible. Okay, so get rid of tan, get rid of reciprocals, get rid of those things. Okay, try to use equivalent identities. Our two most popular ones are sine squared plus cos squared equals 1, and remember it can be rearranged. And the other one that we like lots of times is to come across as sine over cos. And those are our two big ones. Okay, remember your fraction rules. So common denominators when adding and subtracting. Multiply straight across, tops and bottoms. And then when you divide, remember to flip. Use your reciprocal and turn it into multiply. And thirdly, remember we can expand things. We can do FOIL or put number of things in front and distribute. And we can also factor things. Those are handy sometimes. Okay, so the rest of the lesson is just examples. So I'll take you through these identities. You kind of want to think ahead. It's like a puzzle without seeing the top of the box. You have to try and figure out where to go next and what you can work on. We said yesterday we want to work on the more complicated side always. So in this case, I think the left side's more complicated. The first thing I notice is I see 1 minus cos squared. I know, like we just talked about previously, just above here, that as soon as I see a cos squared, I probably want to think about this identity. Oops. Okay, 1 minus cos squared, well, that's the same thing as saying sine squared. So on the left side, I can replace the top part with just sine squared. And we can think to ourselves that sine squared means sine times sine, which means that I can divide. And I end up with sine x. So I've proven left side is right side. Done. And we look at the second one. The right side's obviously more complicated, so we'll work on it. What can I do on the right side? Well, I said let's try and work in sines and coses. So I'm going to take tan x and turn into sine x over cos x. And then because I have fractions that are multiplying, think this is being over 1, I can go straight across. And I'll get sine squared x over cos x. And fractions, when I add or subtract them, and they have a common denominator, which they do, I can turn into a single fraction. Now 1 minus sine squared is kind of like this identity again, but it's the opposite version, right? It's cos squared equals 1 minus sine squared. So, like letter A, I can replace the top with cos squared, and then I can cancel a single cos with a single cos, and I'm left with cos x, which I believe is what we wanted. Left side equals right side. And we've proven it. Okay. I would try these yourself. Pause it, try it, pause it, try it, see what you can do. Okay, which is more complicated? Well, in this case, I'd say the left side because it involves reciprocals. I don't really like reciprocals. I'm going to fix them. So secant is 1 over cos. 1 over cotangent is tangent. I don't really like tangent, though, either. I know that tan is the same thing as sine over cos. I have fractions with a common denominator, so I can write them as a single fraction. And if I stop and look right now, hey, look, that's the answer we want. Okay, that was not too bad. Okay, let's try D. D is obviously the left side, the messy one. So we're going to deal with the left side. Now nothing stands out right away except for the fact that I got fractions and I'm subtracting, which means I probably need a common denominator. If there are two different denominators, we said we can multiply them together. So I'm going to end up with 1 minus cos x times sine x minus 1 minus cos x times sine x. And whatever I do to the bottom, I do to the top. So the first one needs to be multiplied by sine x. The second one, the whole thing, by 1 minus cos x. Okay, let's simplify. On the top, sine times sine is sine squared. On the right side, I'm going to have to do FOIL. But because I have this subtracting sign, I'm going to have to put everything in the brackets when I do FOIL, okay? So 1 minus cos x plus cos x minus cos squared x. And it's a fraction with a common denominator now, a single base, like we did when we did rational expressions. I'm going to simplify and get rid of my brackets at the same time. So I have sine squared minus 1. These two things will cancel each other out, right? And then I have minus, but it's minus negative. So plus cos squared all over 1 minus cos x times sine x. Okay, what do I have on top? Well, I have a mess of things, but if I, a little sneaky for a second here and just change the order, we might recognize something familiar. Sine squared plus cos squared is something we know about. That's 1. This bit is 1. So I end up with 1 minus 1 on the top, and the common denominator is still the same. But when I subtract 1 minus 1, I get 0. And 0 divided by anything, doesn't matter what's on the bottom, comes out to 0, which is what we wanted. So left side equals right side. Okay, so the idea of a common denominator in that one, that was our challenge there. Now try some more. Which side's messy? Well, the left side's got some tans in it. I can fix tans. Tan is sine over cos over cos. Now, we don't like fractions divided like that, so let's fix the format. It's sine over cos divided by cos. How do we divide fractions? We take the second one, we write the reciprocal, so it's 1 over cos now, and we turn it into multiplying. Multiplying fractions, we go straight across. Sine times 1 is sine. Cos times cos is cos squared. Look back to our question. We wanted to end up with a 1 minus sine squared on the bottom. Well, what do we know about cos squared? Well, if we go back to that first identity, the Pythagoras one, here's where it's coming from, right? Cos squared is 1 minus sine squared. So I can replace, and now I have left side equals right side. I'm going to try the next one. Again, pause, try them yourself, please. What do we get this time? Left side obviously messy. So sine squared plus sine x cos x. Get rid of that tan. Sine x over cos x. Well, that's what we did last time where we got rid of that dividing sign. And we wrote it as sine x over cos x. But we don't like dividing fractions the way they are. We like to use reciprocals and turn it into multiplying. And now, because it's multiplying, I can cancel a sine with a sine. So we're left with sine squared plus cos times cos. Or in other words, sine squared plus cos squared. And what do we know about that? That looks kind of like this one. 1. Left side, right side. And that's it. Okay? Identities. You have to practice. You have to try them yourself. I can make them look easy because I've done them all the time. But if you don't practice them, you won't figure them out.